Hello everyone and welcome to today's Review Bite, covering the topic of symmetry from pre-calculus. Goals for this video are we are going to be able to recognize both odd functions and so-called even functions, whether we're given the equation of the function or the graph of the function. We see that a function is odd if it has the following property. If you go into the function and replace all the inputs, all the x's, with the expression negative x, and you simplify that, then you get the same answer as if you applied a negative sign to the outside of the function and simplified that. Let me show you what I mean. Take, for example, this function in the upper left, 4x to the fifth power minus x to the third power plus 2x to the first power. This function is called odd, and if I wanted to justify the claim that this function is odd, then here are the steps that I would take. First, I would have to see what happens if I go into the function and replace all the inputs with the quantity negative x. If I replace that x with negative x in all three of these positions, and I use the exponent properties to simplify the result, and I get this expression right here, negative 4x to the fifth power plus x to the third power minus 2x. Now, let's also see what happens if I apply a minus sign to the outside of the function. If I apply a minus sign on the outside to this function, then I get negative quantity 4x to the fifth power minus x to the third power plus 2x. And if I distribute and simplify that, then I get exactly the same result that I got in the previous paragraph. So we can see that these are the same result, f of negative x and negative f of x, and because those are the same, we call this function an odd function. Now notice something interesting about this function. This function is a polynomial, and all the powers on all the x's are odd numbers. X to the power 5, that's an odd number. Power 3, that's an odd number. And power 1, that is an odd number. And it's examples like these, polynomials with odd powers, that gave rise to this name odd to describe functions that have this kind of property. Another example of an odd function. I claim that this guy here is odd, x times the square root of 4 minus x squared. Once again, if I wanted to verify that this function is odd, then the first thing that I would have to do is go into the function and replace all the x's by negative x. So I replace this x in the front with negative x, and I replace this x under the root with negative x. And the result of that replacement simplifies to minus x times the square root of 4 minus x squared, which is exactly the same as what I would get if I applied a minus sign to that same function on the outside. So these two quantities match, and because of that, this function would be called odd. Another example, the function sine from trigonometry is an odd function, and that follows from the trig properties, from the unit circle properties. So sine of x is also odd because sine of negative x is the same thing as negative sine of x. Now to give you an example of a function which would not be odd, let me give you this function x cubed plus 2. I claim that this function is not odd, and to that end, let's go ahead and check to see what happens if I plug negative x in to replace x in this function. If I replace the x's with negative x, then in the front I get negative x quantity cubed and then plus 2. And if I simplify that, that's negative x cubed plus 2. However, that is different than what you get if you apply a minus sign to the entire function on the outside. Here I get negative x cubed minus 2, minus 2. So there's a mismatch in this sign in the back, and these two functions, these two expressions are not exactly the same. And because they're not exactly the same, this function would not be called odd. Now, odd functions have a beautiful graphical feature. When you graph an odd function, then the left half of the graph and the right half of the graph are very closely related to each other. If you look at the left half of the graph, then this is a mirror image of the right half of the graph, just flipped upside down. Let me show you what I mean. So here is the graph of the function sine, and here is the right half, and here is the left half. If I take the right half and I take its mirror image and then flip it upside down, then I get exactly the same thing as what I'm seeing on the left half of the picture. This hump here on the top right shows up again identically on the bottom left, for example. So this graphically would be an odd function, the odd function sine of x. Here is another example of a graph of an odd function. Here we see that the right half and the left half are almost identical. The main difference is that the right half, if I flip it horizontally and then flip it upside down, if I flip it upside down on the left side, then those match. Likewise here, this is another graph of an odd function. If I take this right half of the graph, then the left half of the graph is basically almost exactly the same, except it's been mirrored horizontally and then flipped upside down. So mirrored and then flipped. This is the graphical feature of an odd function. Let's also talk about even functions. A function is called even if it has the following property. If I plug in negative x in x's position and simplify, then the result of that simplification gives me back exactly the same thing as the original function I started with. Here's an example of an even function, 4x to the fourth power negative x to the second power plus 2. And so notice that we have this polynomial and all the exponents on all the x's are even numbers. Very interesting. I claim that this is an even function, and if I wanted to confirm that that was true, I would have to go into the function and replace each of the x's with the quantity negative x. And if I did that, I have 4 times negative x to the power 4 minus negative x squared plus 2, and simplifying that using the exponent properties gives me back 4x to the fourth power minus x squared plus 2. And that's exactly the same thing as the original function f of x that I started with. As a result of that, this function would be considered even. Here's another example of an even function, the square root of the quantity 4 minus x squared. This function is even, and we can confirm that by going into the function and replacing all the x's with the quantity negative x. And when I do that, and I take the square root of 4 minus negative x squared and simplify that result, then I get exactly the same function that I started with. For a final example, we have cosine. Cosine, by the trigonometric properties, by the unit circle properties, is even, because if you plug in negative x to cosine, the result is the same as if you plugged x into cosine. So this would also be an example of an even function, cosine. For an example of a function which would not be considered even, let's have a look at this polynomial here, x squared plus 4x. This function I claim is not even because if I replace the x's in this expression with negative x and then simplified, then the result of that simplification would be x squared minus 4x. And here we have that minus sign as compared to here we have that plus sign. Because this is not an exact match to the function that we had originally, then this function would not be able to be called even. Now, as odd functions had a special symmetry when they are graphed, even functions have a special symmetry when they are graphed. The symmetry displayed by the graphs of even functions is as follows. If you take the right half of the graph, then the left half of the graph is going to be an exact mirror image of the right half, right side up this time, as opposed to odd functions, where the left half was upside down. To show you what I mean, here is the graph of cosine. Here is the right half of the graph to the right of the y-axis, and here is the left half of the graph to the left of the y-axis. And we can see that the right half and the left half are exact mirror images of one another. Likewise, this is an even function, and its graph also has this property that the right half and the left half are exactly the same mirror images of each other. This is also a graph of an even function. The right half and the left half are exact mirror images of one another.